This is Notes 5.4, Intro to y equals mx plus b. Y equals mx plus b is called slope-intercept form, where m is our slope and b is the y-intercept. To graph a line, we can start with the y-intercept, and then we can use the slope to find our other points using rise over run. Number 1. Graph the line y equals x. This is in the form y equals mx plus b. Remember that if there's no number in front of that x, then the coefficient is a 1. So my slope is 1. If I'm thinking rise over run, this is going to be up 1 over 1. My y-intercept, I notice that there's nothing in the spot where the y-intercept should be, so this is the same as having plus 0. This means the y value is 0. And for all y-intercepts, the x value is always 0. So for this equation, my y-intercept is the origin. So I'm starting at my origin, my y-intercept of 0. My slope, rise over run, is up 1 over 1, up 1 over 1. Once I have a few points on my graph, I can draw my line. Remember, this line goes forever and ever, so I should have arrows on both ends. X-intercept is where my line crosses the x-axis. On this graph, I notice that my x-intercept is the same as my y-intercept. It crosses at the origin. 0 is the same thing as an x-intercept, so my 0 is also the origin, the point 0, 0. I notice that this line goes to the left forever and ever, and to the right forever and ever and ever. So my domain is all real numbers. It also goes down forever and ever, and up forever and ever, so my range is all real numbers. This equation, y equals x, is called the linear parent function because this is the simplest equation of a line that we can ever have. Number 2, graph the line y of x equals negative 3 over 2x minus 3. Remember, this function notation is just the same thing as y equals, it's just giving our function a name. This is in the form mx plus b. So my slope is negative 3 over 2. This is my rise over run, so I will go down 3 because it's negative over 2. My y-intercept, I need to be careful. I'm always looking at the sign in front of that number. My y-intercept, or b value, is negative 3. As an ordered pair, this is the point 0, negative 3. So, starting on my graph, I'm going to start at a y-intercept of negative 3. I go down 1, 2, 3. And my slope is negative 3 over 2, or down 3 over 2. Going this direction, I'm running out of room, so I'm going to reverse it and go up 3, left 2. And once I have my points, I can connect my dots to draw my line. For x-intercept, I'm looking, where does my line cross the x-axis? This line crosses at the point negative 2, 0. And remember, a 0 is the same thing as the x-intercept, so my 0 here is also negative 2, 0. Y of negative 2. Function notation, this tells me I want to know what is the y value when x is negative 2. On my graph, I find where x is negative 2. My line crosses x is negative 2 at the point negative 2, 0. So my y value there is 0. Y of negative 2 equals 0. Y of x equals negative 6. x equals, this is telling us the y value is negative 6. So on my graph, I'm looking where y equals negative 6. I see the point, and I want to know what is the x value at that point. The x value is positive 2. So I say that x equals positive 2. Is this graph increasing or decreasing? We're always looking from left to right. Going from left to right, this graph is going down, so my line is decreasing. Number 3, graph the line g of x equals negative 4x. This is in the form y equals mx plus b. My slope, my coefficient of x, is negative 4. So if I'm thinking rise over run, this is negative 4 over 1. I'm going down 4, right 1. I notice that I do not have a plus b, so my y-intercept is 0. Remember, the x value for a y-intercept is always 0. So my y-intercept is actually the origin, 0, 0. Using my slope, I'm going down 4 over 1, down 4 over 1, and I can go back the other direction, 1, 2, 3, 4 over 1, 1, 2, 3, 4 over 1. I connect my points to draw a line. The x-intercept is where I cross the x-axis. I cross the x-axis also at the origin at 0, 0. And remember, the 0 is the same thing as the x-intercept, so my 0 is also the origin, the point 0, 0. G of negative 1, this is telling me x is negative 1. Find y. So I'm looking on my graph where x equals negative 1. And I see that at that point, my y value is 1, 2, 3, 4. So g of negative 1 equals 4. G of x equals negative 4. This is telling me that y equals negative 4. I need to find the x value. So going to where y is negative 4, 1, 2, 3, 4. The ordered pair where y is negative 4, x value is 1. So I would say x equals positive 1. Increasing or decreasing, remember we're looking from left to right. From left to right, this line is going down, so my function is decreasing. Take a look at number 4. Graph the line y equals 1.2x minus 4. This is in the form mx plus b. My slope here is 1.2. However, that's not very useful for us because we cannot use a decimal to find rise over run. So I need to convert this decimal to a fraction. 1.2, math, enter, enter, gives me 6 over 5. So up 6 over 5, rise over run. My y-intercept, remember I'm always looking at the sign in front of that number. So my y-intercept is negative 4. The x value for a y-intercept is always 0. So I'm starting my graph at a y-intercept of negative 4. And I'm going up 6, 1, 2, 3, 4, 5, 6, over 5, 1, 2, 3, 4, 5. Up 6, 1, 2, 3, 4, 5, 6, over 5, 2, 3, 4, 5. I may have room to go back the other direction, so 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. I connect my points to draw a line. X-intercept, I'm looking for where my graph crosses the x-axis. It appears that this does not cross the x-axis at a specific point. So we're going to use what we know about x-intercepts to solve for that point. So notice on the front, for all of my x-intercepts, the y value is the same. The y value is 0 at every y-intercept. So for x-intercept, I'm going to use a y value of 0. And I'm going to solve this equation for x by plugging in 0 for y. 0 equals 1.2x minus 4. Solving for x, I add 4 on both sides. 4 equals 1.2x. I divide by 1.2 on both sides. 4 divided by 1.2 gives me 3.33, or as a fraction, math, enter, 10 over 3. So my x-intercept is the point 10 over 3 and a y value of 0. Remember, 0 is the same thing as the x-intercept, so my 0 is 10 over 3, 0. Increasing or decreasing, I'm looking from left to right. From left to right, this line is going up, so my function is increasing. Notice that anytime we've had a positive slope, our function was increasing. Decreasing was when we had a negative slope. Number 5, graph the line that contains the point 0, 6, and has a slope of negative 3. So I need to start at this point 0, 6, 1, 2, 3, 4, 5, 6. Notice that since this is on the y-axis, this is actually my y-intercept. So my y-intercept is the point 0, 6. Slope of negative 3. So if I'm thinking rise over run, I'm going down 3 over 1. So 1, 2, 3 over 1. 2, 3 over 1. I'm going to go back the other direction also. 1, 2, 3 over 1. I connect all my points to draw my line. X-intercept, I'm looking for where does this graph cross the y-axis. I cross the y-axis at the point 2, 0. So my 0 is the same thing, the point 2, 0. Increasing or decreasing, remember I'm looking for left to right, or I'm looking at the sign of my slope. From left to right, this function is going down. So my function, or my line, is decreasing. My slope was also negative 3, so that negative also tells me that my function should be decreasing. Equation of the line, y equals mx plus b. I have the slope. My slope is negative 3x. Keep the x. For y-intercept, the b, I'm using the y value of that point. It's positive, so plus 6. My equation is y equals negative 3x plus 6.